So let's just start with polar coordinates. So let's say I have the coordinates. So our radius is 7, and our angle in radians is 3 pi over 5. Pause the video and see if you can convert that into rectangular coordinates. Well, the key here is to recognize that x is going to be equal to r cosine of theta, and y is going to be equal to r sine of theta. So in this situation, our x-coordinate, I could write it like this, is going to be 7 times cosine of 3 pi over 5, 3 pi over 5. And then our y-coordinate is going to be 7 times sine of 3 pi over 5. Now, this is correct, but if we actually wanted to approximate what numbers these are, we could put them into our calculator. So here we have our calculator. Let's make sure we're in radian mode. Yep, we are in radian mode. And so if you were to take 3 times pi divided by 5, that's that, times cosine, not times cosine, we're taking the cosine of it, times 7 is equal to, I'll round to 3 decimal places, so negative 2.163 approximately. So this is, that right over there is approximately negative 2.163. And then if we were to do the same thing for the y value, we would take, once again, 3 times pi divided by 5 is equal to, take the sine of that, and then multiply that times 7. That's approximately 6.657. So this is approximately 6.657. Now let's look at an example where we go the other way. And let's do this one in degrees. So let's say I was given the rectangular coordinates. Let's say I'm given the rectangular coordinates negative 2, 11. Pause this video and try to write that as polar coordinates. Well, in other videos, we have seen that r is going to be equal to the square root of x squared plus y squared. This comes straight out of the Pythagorean theorem. And theta is going to be equal to the inverse tan of y over x. Now, we have to be careful here because the inverse tan, let me give you an example here. The inverse tangent, actually we'll see it when we do this example. If you just take the inverse tangent, if we're thinking in degrees, it's going to give you an angle between negative 90 degrees and positive 90 degrees. But we might have, so something in the first or fourth quadrant. But what about when the angle is in the second or third quadrant? So we have to think about that, and we might be in a situation where we want to add 180 degrees to it. So maybe we could say, right, plus k times 180 degrees, where k is 1 or 0. So maybe that, yeah, that's a reasonable way to say it. But or another way to think about it is we might add, so plus 180 degrees. I'll put in parentheses here, where we're going to have to think about where our angle is. So let's start with r. That's pretty straightforward. R is going to be equal to the square root of negative 2 squared is 4. 11 squared is 121. So it's equal to the square root of 125. And now let's think about the inverse tangent. So if I were to just take, let's think about what quadrant we're in. So this is our x-axis, that's our y-axis. We're at negative 211. So negative 211, I could think about being right over there. So that's in the third quadrant. So our r is going to look like this. And this is our angle. This is our angle right over here. That's the theta we want to solve for. But if we take the inverse tangent of y over x, it's actually going to give us this theta. Maybe I'll call that theta prime. So what we want to do in this situation is whatever, when I take the inverse tan of y over x, I want to add 180 degrees to it to get to our actual theta. So in this situation, theta is going to be equal to the inverse tangent of y over x, so that's negative 11 over 2, or 11 over negative 2, which is negative 11 halves, and then plus 180 degrees, if we are doing this all in degrees. So let's get our calculator out. So that first part, we could just straight up take the square root of 125. So it's roughly 11.1, I'll go to 3 decimal places again, 11.180, I'll just do 11.18. So this is approximately 11.18. And then the angle, let's make sure that we are in degrees, because we want to do this one in degrees. We could have done it in radians, in which case we wouldn't be adding 180 degrees. We'd be adding pi if we were doing it in radians. But let's now, whoops, I'm trying to clear this out. All right, I want to take 11 divided by 2. Well, I could have done that in my head. And then I want to take the negative of that. And then I want to take the inverse tangent. I don't see tangent. I have to press second here, and I have inverse tangent of that. And notice, it gave me the angle of negative 79 point whatever degrees. I have to add 180 degrees to get to my actual angle. So plus 180 is equal to roughly 100.3 degrees. So theta is approximately 100.3 degrees. So if I were to write it in polar coordinates, at least the approximations, it's 11.18, comma, 100.3 degrees. And I'm done.